everyone. We are going to be finishing today the Part A version of Chapter 9, Sampling Distributions of Proportions. And I want to take you through the essential steps that you would do in a real-life analysis of data. Right, so suppose that you're interested in knowing something. It could be anything at all, as long as it's got a percentage in it. So you're interested in finding out what percentage of people like Coca-Cola. That's probably not the most inspiring one, but maybe who's going to win the next election? Or what percentage of people are in favor of abortion? Or have things changed? As the people who are in favour of abortion, has it increased in the last 10 years, stayed about the same? Has it decreased? You want to find people's opinions. Well, as long as you can answer or ask the question in a way that they can say yes or no to, then we can do this technique. So basically there's 5 steps to it. First step is you've got to collect good data. That is almost always going to be a sample. And if you can really do it, the best kind of sample has always been a simple random sample. But whatever, you've got a sample. So you collect some data, and I say good, we want it to be unbiased, right? You ask the question in a nice, fair way. The people that you asked are a fair representation of the entire population. Then you do this little guy, which is new. For us to do all the stuff that we did yesterday, we made one very big assumption, and that was that the data was normally distributed. Well, not all data is, but there is a simple test that we have to get beyond, and it's this test here. The size of your sample times p hat must be bigger than 10. You might argue equal to, I wouldn't disagree with that. And so should that be. So let's suppose that I do a sample of a tiny sample of 20 people. And 5 people out of that 20, right, said, yes, I like sci-fi movies, whatever the question was. In p hat, which is basically 20 times p hat, oops, equals 5. Isn't that essentially the number of people who said yes? And then, if you do n 1 minus p hat, that's going to be 20 times 15 out of 20. And that's 15. And that's the number who said no. You cannot even do the standard error, the normal distribution, making intervals, or any of that stuff unless this is true. This is the fence that you have to get over before you can do that technique. What it does is it stops people from making tiny little samples of 3 people and then making huge, wildly inaccurate predictions based on it, just because they had 100% success rate. You know, the 3 people I asked said yes, the answer's 100%. Brilliant. Well, in real life, that's not brilliant. That's just a very small sample, and anything could happen when you do a very small sample. So we don't want to go there. So that's how we stop it. So NP hat is essentially the number in your sample who said yes, and N1 minus is no. So it has to be at least 10 people in both groups, or you stop right there and say, we cannot do this analysis, right? We're not going to do it because we know it's not really accurate. So you get by that, and then you calculate this. So let me make a story up. Let's suppose that we asked a bunch of high school students, do they watch, do they watch or play, probably both, American football? And in our sample, 250 of them, 112 of them said that they played or watched American football. When you look at this, can't you tell that n p hat is 112? Agreed? You don't need to do a multiplication to know that. Isn't that the 112 that said, yep, I play football, or at least I watch it? The other one of the two, you have to kind of figure it out. That one, right? Isn't that the rest? So you could just calculate it, 250 times that, 1 minus that. But if you do the ones that are rest, what's that? 138. So haven't we passed step 2? And we'll assume, number 1, that we got good data. So the 250 students we asked were a fair representation of all students at that school, right? You wouldn't go to, I'm trying to think of a bad group. You wouldn't go to the poetry club and ask the ones in the poetry club, do you like football or do you play it? Because couldn't they be a different representation of the rest of the students, right? Can't think of a good one, but that one will do. So, we've got good data. You've checked this and you got yeses. Yes, yes. Moving on, next thing we do is we calculate the standard error. In this case, I'm going to turn this into a decimal. It's just so much easier to work with decimals. So 112 divided by 250 is 44.8%, if you prefer. And there is a formula for the standard error. It's p hat, 1 take away p hat over n. And so in this case, it's going to be 0.448. 1 minus p is just 1 take away that number. So whatever's left. So what do you get? 0.552. And then you divide by the sample size, which in this case is 250. And then we go to our calculator and we go square root of 0.448 times 0.552 divided by 250. And the answer I get is about 0.031, rounded off to 3 decimal places. Now, once you know the standard error and you've already calculated P, you then can create one of these intervals. Depends on what they ask you, but the most common one that you're going to be asked is the 95% one. So what does that look like, 95%? Well, the formula for calculating it is the sample, p hat, plus or minus how many standard errors to get a 95%?
2.
2. If they did ask, which is unlikely, but if they asked you for a 99.7, wouldn't it be 3? And I hope they never ask you for 68. Do you know if you do a 68, aren't you going to be wrong 2 out of 3 times? In other words, your interval, right, has 68% chance that the answer is in it, right? Isn't there another 32% chance it's miles away? I don't think that is even, I would just never use it. I don't think it's a good idea. That one's pretty good, right? 95% chance. I mean, that's excellent, but maybe just a little bit too strong. So let's say we have a p hat, which is 0.448, and we add or subtract 2 standard errors, and that becomes 0.448 plus or minus 0.062. And yesterday, I told you the name that we give to that piece, the plus or minus 0.062. What's that called? It's actually 3 words, but what's its name? Last chance. It's called the margin of error. If you ever watch a news program and they start talking about surveys and polls, polls just another name for a survey. They should tell you, they don't always, but a lot of the time they do, they should tell you the margin of error. Oh, we've just conducted our latest poll on people's opinion of President Biden, and 42% are in favor of him, think he's doing a good job, and the margin of error is plus or minus 3%. Right, that's kind of how it does. Now, even if you can't remember, you've probably heard sentences like that, right? The margin of error was plus or minus 2, 3, 4%, which is typical number that you get in these questions. Now I'm going to take this away and add this together and just taking no chances. 0.448, take away the margin of error, and that comes out to be 0.386, and I'll do it in English, up to 0.448 plus 0.062, and we have this number. As an interval, you would write it something like this. And if you like percentages, which I do, you would probably write it like this. Right. So it's time to get, that's basically step 4. And step 5 is you can very often make a conclusion then based on this interval. What this interval is telling us is that based on the one sample that we did, this guy here, we're 95% sure that the real answer, right, for the entire population is somewhere between 38 and 51%, right? We're not 100% sure. Isn't the only way to be 100% sure is to do a census? You ask everybody, right? But we're 95% sure that the real answer is somewhere in this range. So the conclusion depends on what you were being asked. So for instance, suppose you were told that it was believed that the percentage of students who watch or play American football was 30%. So suppose you're going to compare it to 30%. Is this interval evidence that the answer is 30%? No. Wouldn't you be able to say, well, we've conducted the sample and you were wrong. It's definitely more than 30%. Would you agree? Maybe they tell you, well, we thought it was 60%, right? Because, you know, that's what our gut feeling was, that 60% of teenagers like football. Well, wouldn't this be evidence? Nah, you're not. 60%. It's less than that. So you can make a conclusion based on the numbers that are in the interval. Now, if they said they thought it was 47%, couldn't you say, yeah, that could be true? I mean, 47's in there somewhere. In fact, couldn't you say 50%? Yeah, that's probably true as well. But you can, the extremes are actually more interesting because those evidences are stronger. Isn't it much stronger to say that it's definitely not 30%, it's bigger, or it's definitely not 60%, it's smaller, right? Those are much stronger pieces of evidence than saying, well, it could be 44. Yeah, you're right, but it could be 42 and 38 as well, you know? So there's a lot of numbers that could be not as strong as what it isn't. Any questions about that start to finish process? Because that's how you should really do one if you wanted to do a really good statistical analysis on anything at all. So I've collected some data. far as I know, this data is good, but I didn't check it. I didn't go and look for other sources. But in 2005, the percentage of adults who smoke was 20.9%. I could believe that, and that's what I read at least. And this is to pretend samples that I did, right? So I'm pretending we did this, and I want to look at these two and see whether or not this works, right? And we're interested to see, actually, has the percentage of people who smoke going down? So in my little story, a few years ago, I asked 100 adults how many of them smoked, and the answer I got was 18. And then a couple of years later, last year, I went and got some money, and I asked 1,000 people in my sample and 180. First thing, because this is a made up thing, is, do you notice in both cases, because I deliberately made this happen, would you agree that raw data, it does look like the percentage has gone down, right? It used to be 20 and a bit, and now it's 18%, agreed? But we know that samples, you can't just use that number from a sample and say, hey, I've proved it. Because when you do samples, don't you get randomness? Maybe the people I got here were a little bit less smokers, could happen randomly, and the real answer is still that number. So what we have to do is we have to go through our kind of 5-stage hit process, and we'll test this data to see whether or not we can prove that it's gone down. And then we'll try it with this one, and we'll see if we can get it to go down. So we might find that both of them prove it, none of them prove it, or maybe just one of them proves it, right? All three are possible. So here is my data. Step 1 and step 2, I'm going to say are done. Let's remind you, step 1. Can we pretend that I got good data, right? And it's pretty clear, isn't it, here, that 18 said yes and 82 said no. So aren't we beating the 10 rule, right? So we'll take that as granted. So what I'm going to do is go straight into step 3. We have p hat is 0.18 and that the sample size is 100. So I'm going to do the standard error of p hat, which is this guy. In this case, 0.18, 0.82, and it's going to be divided by 100. Square root of 0.18 times 0.82 divided by 100. And the answer I got here was 0.038. Yeah, 3 decimal places. And I'm going to analyze them the same way. I'm going to find a 95% one, right? And so it's going to be p hat plus or minus 2 standard errors. So it's going to be 0.18, give or take 2 of these guys. It's going to be 0.18, give or take 0.076. And on the small side, that's going to be, well, let's not just risk it. 0.18, take away the margin of error, 0.076, and I get 0.104. And then if I go 0.18 plus 0.076, I get 0.256. And if I make them percentages, because it just works in my brain better, the interval that I got is that. Let's see what our conclusion is. Is this proof that it's now less than the 2005 figure of 20.9%? We're 95% sure that the real answer is somewhere in this range. Does this prove that it's actually less than 20.9? Well, not really. Couldn't the answer be 25? Couldn't the answer still be 20.9? Couldn't the answer have went down and been, 12%? But aren't all those answers equally likely? And so I can't prove that it's less than. Now, if the question was, could it be still 20.9? You could argue that, couldn't you? It could be, right? It's in the interval. But that's not what I'm asking. I'm asking, is this evidence to prove that it's definitely less than 20.9? And the answer is really inconclusive. Right, I haven't proved it. What do you think the problem with what I just did? Why didn't I get evidence, or what? If there was evidence to find, at least, why didn't I find it? I wouldn't call it a flaw, but what's the problem? What did I do that I might have been able to do better?
The sample size could have been bigger.
Yeah, that's pretty much the answer to every problem. Just ask more people, because if you use a bigger sample, don't you get more accurate results? And if you get more accurate results, if what you're hoping to prove is in fact true, you'll eventually get it, right? You'll be able to get evidence for it, but not right now. So that's the first one. And so the first one, inconclusive. We didn't manage to prove that it's actually gone down. Now, I don't know if the second one is going to work or not, but that's the fun of doing these. Pretty much a carbon copy of this, just with slightly different numbers. So 1 and 2 we'll assume have been done. We're on to finding the standard error. So we know that guy is still 0.18 and that the sample is now 1,000. And so our standard error will be the square root of 0.18, let's put it here, 0.82. Did you see the only difference is that I'm now going to divide by 1,000 instead of 100. So won't that make the standard error smaller? Let's see how much smaller. Square root of 0.18 times 0.82 divided by 1,000. And the answer that we get is 0.012. Okay. Let's get our 95% or one. So our 95% confidence interval is p hat, give or take 2 standard errors. 0.18, give or take 2 of these guys. Give or take 0.024. And 0.18 take away 0.24. Let's try that again. 0.18 take away 0.024, that's better. We get 0.156 and 0.204. And as a percentage, that is 15.6% up to 20.4%. And now conclusion. Is that interval, which is telling us what the real answer is, it's somewhere between here and here. Is that proving that it's now less than 20.9%? Yes. Aren't all of these numbers less than 20.9, right? So whatever the value is, it's one of these guys. And no matter which one of them, they're all less than that. So yes, we have proved it. Now, do you notice in my story, the only difference was sample size, wasn't it? I kept all the other numbers the same, right? P hat was the same in both cases. So the moral of that story is you should always make your sample as large as you can afford. Right? If you've got unlimited money, you know, make your sample huge. Because if you do, you get really, really good results. And then you could publish that. And you could publish it in, I don't know what medical journal it would be, or social science probably. There has been a distinct change in the smoking habits of Americans over the last 7 years. We conducted a sample, right? And using a 95% confidence interval, we managed to prove that the percentage has gone down. You could, if you were pushing your luck, couldn't you say by at least 0.5%? Right? Difference between there and there, right? At least 0.5%. But it could be as much as, well, you take that away from that and you get, it could be as much as 5.3%. You know, I'm just using the extremes, right? Any one of those numbers could be true. If it was this one, it's definitely 0.5% reduction. If it was this one, it's, well, you know, 5%, 5.3% reduction. So you can actually add a little bit more information to your, yes, it's gone down. Now you can say by roughly how much you believe it's gone down. Any questions so far? So this is the structure that you should be using, or one of the structures. We'll do more sophisticated ones in the future, of finding evidence to prove something, right, in a proportion world. So next question is going to be from the homework, just to show you how the homework does the same type of thing. It's not exactly the same as mine, but it's pretty close. There we go. So here, where are we? Okay, so this should be question 8 from our homework, chapter 9. Suppose that a medical researcher thinks that 70% of all teenagers with high blood pressure, oh no, we've done the calcium one, I'm not doing that again. Right, let's do, yeah, let's do this one here, question 9. An automobile club comes to the aid of stranded motorists who are members, like AAA. Over the long run, about 6% of the members utilize this service in any given year. Okay, I'll take your word for that. A small town of 300 members, so there's more than 300 in the club, but 300 are in the club. Right? So we consider this 300 members to be a representative of the larger club membership. Okay. Let P hat be the proportion of them who will utilize this service in the coming year. So let's see what their questions are. You know, WebAssign likes to make a meal of some things. Explain how the following conditions for approximately normality of a sampling distribution for the sample proportion are met in this scenario. First thing, the physical situation. Either there is an actual population with fixed proportion who's have a trait or opinion of interest, or there is a repeatable situation. Well, isn't there an actual population of people who are members? It's not a theoretical thing like, well, I could roll the dice 20 times kind of thing, right? It's actually people out there, right? either a random sample is selected from the actual population, or you just repeat it. You don't really do the repeat numerous times in these kind of stories. A repeat numerous times would be testing if a dice is fair, right? You have one dice, you keep rolling it for as many times as you want. That would be an example of that situation. So here is that one. And they've got the NP, N1 minus P. So what do we have here? They told us it was 6%, didn't they? Yeah. So NP would be 300 times 6%, which I believe is 18. So 18 people in that town would end up using AAA. And the other one is the other 282. Do you see, I don't need to do a calculation for that, because aren't the yeses the ones who use it and the no's the ones that don't? Don't they always add up to 300, right? But the important part is, aren't they at least 10? Would you agree, 18? So that's good. If either one of them was a number less than 10, like 5 or 9, you would stop right now. You wouldn't even bother doing the rest, right? Because statistically, that's very dangerous. In this case, we know that this is 300. So there we go and repeat ourselves. And we know that P is 6%. The sampling distribution of P hat is normally distributed. Its mean is 6%. And its standard deviation, right? Standard error, standard deviation, right? They're almost interchangeable. Won't that be the square root of P, 1 minus P over A? Right. So I got my calculator here. And I'm going to do that. It's the square root of 0.006, which is P, times 0.94, which is Q, divided by a sample of 300. And I got well, did they tell me how many decimal? 4 decimal places, okay? So 0.0137. Okay, can I pause there? Are you comfortable with the way that WebAssign asks those questions? Do most of them make sense to you? Or do you need me to go over something? Are we good? Okay. Now, a towing service in the town is contracted with the club to come to the aid of up to 21 members. Okay, how does that work? Okay. Can you imagine that AAA, or whatever the company is, they may make a contract with a towing company? And there are a couple of ways they could do it. One of them they could say is, we're going to pay a fixed rate, right? Every time you pick someone up and take them to a garage, we'll pay you $100, right? Or $200, right? Or they might just give them like a retainer fee, right? Here's $10,000, but you guarantee to pick up 23 or less people, right? That's what we've contracted you for. You've got to do that, right? Once you've got to your 23rd one, our contract's over for the year, right? We'll have to find somebody else to pick them up. A little weird way of doing it, but that's how they're doing it. And there's 21 members. What proportion then of the town gets picked up? So in this question, it ends up being 7%. Agreed? 21 out of 300. That's 7%. Okay. Well, that's okay. Isn't the average 6%? So if they're contracted to do about 7%, the chances are that they're going to cover everybody. But then they finish with, what is the approximate probability that the actual proportion requiring aid will exceed this value? So they're basically asking you to find the probability that X is bigger than the 7% that they've paid for. It's a normal distribution. Oh, let me go. I'm going to go back to this question, but I want to write some things down now because I've spoken too much and you might be losing the track of it. We know that the sampling distribution has a mean of 0.06 and a standard error of 0.0137, right? And we're trying to find the probability that the number of people who do need the help is bigger than the 7% that they've contracted. So we have a normal distribution with a mean of 0.06 and a standard deviation, which is just another term for that guy, of 0.0137. Now, if you imagine where 7% is, it's about here. Aren't we trying to find that guy? Right, now I'm going to go back because we're going to use salt. In fact, I think this is the only question in this section where you do use salt. There it is there. So I'm going to click on that guy. I'm going to bring him over here. Now, it's been a little bit of time, but hopefully not too long since we've used salt on these distributions. Normal distribution, yep. The mean is 0.06. The standard deviation is 0.0137. And we want to do bigger than, right, over here. And we want to do bigger than 0.07. And the answer is here. So that means, according to the data that we've got, there's a 0.23, don't know how many decimal places. Let's call it 0.23. Doesn't that mean that there's a 23% chance that in this small town, there are going to be so many breakdowns, right, that there's a 23% chance, right, that they won't get picked up by that company. Share some with you. Me and my wife have an RV. We just got it last year. COVID made me want to get out more, and it's kind of hard to get out places, so we took our house with us. It's a little RV, but we got insurance, kind of like the AAA. And what they do is they will pick you up if you're, if your RV breaks down, and take it somewhere. And I watched a video about someone who was telling us about different companies, and I'm not mentioning the company, it's not important, but they said, don't use company A. And what had happened is that company A probably did a deal something like this, right? RVs are a little bit different, right? But they pick them up and they tow them, right? When something goes wrong and the axle breaks or something, right? And they said, don't use them, because this company was so small that they had contracts with various garages, but the garages were very far apart, like over 100 miles from one to the next. And some of them wouldn't pick me up because they'd already done their, well, we're only contracted to do like 23 and I've already done 23, so don't ask me, isn't a big problem. And it took them a ridiculous amount of time. And the guy that they eventually got to pick him up was like miles away. And so that's what that reminded me of. That if you're a company, are you willing to live with 23% of your people unhappy? If you did AAA and then AAA says, yeah, we'll pick you up, but the pickup truck's in California because that's the nearest one we've got, because we're a very small pickup, we're a very small company, would you probably not want to use that company, right? Or 23% of the time, we can't help you directly, we're going to have to find somebody else. Are we good? Right. Yeah, okay. I think there's one last question in this kind of group, so let's do that one, and we'll be finished for today, so that's kind of good timing. Can never find things when I want them. Where are you hiding? Oh, here you are. Let's do question 10. An automobile club comes to the aid of stranded motorists or members over the long run, about 7% of them. So they're telling me that P is 0.07. And this town has 170 members, so we'll do that. And this question is asking us to do a 95% confidence interval. So let's see what that looks like. So we're told this guy, sample of this, get a 95% confidence interval. Well, I should be able to get the standard error. If they tell you that number as a proportion number, call it P. If they tell you that number as a sample number, just call it P hat. But you could use the exact same formula, and they only tell you that, guy. So if you're wondering where the hats went, it's because that number was a population number. So it's going to be 7%, 93% over 170. These numbers must be decimals. You could do fractions if you like, but they're too awkward. So 0.07 times 0.93 divided by 170. And the answer that we have is 0.0. What do they want accuracy here? Oh, the nearest hundred, so that's 0.02. The nearest hundred is just another way of saying 2 decimal places. And since they want a 95%, it's going to be P hat, give or take 2 standard errors. So it's 0.07, give or take 2 of these guys. So 0.07. So it could be as low as 3%, and it could be as high as 11%. So this company would make a prediction that in this town, 95% of the time, when you get somewhere between 3% of them needing help, and it could be as high as 11, right? Suppose this town had 20% people using it, just for argument's sake. Would you be suspicious if you were a company that there's something weird going on here? Would you agree 20% is a lot bigger than the interval suggests it should be? Now, it could be that that particular town has an awful lot of very old cars that break down a lot of times, right? That could be the reason for it, right? In other words, that town's not typical for the rest of America. Couldn't it be maybe an indication of fraud? You know, the tow companies charge the AAA for doing these tows. And can you imagine an unscrupulous guy saying, hey, George, you're a member of AAA. Do you want to pretend your truck's broke down and I'll pretend I pick it up and we'll split the money that I get? Just saying that is because I'm a suspicious person, right? Could be evidence of something bad going on. Okay, well, last name, bye-bye.